Hello everyone. In this video I'll show you how to connect controllers for hub motors. I've bought a hub motor for myself. I'm going to install it on my bicycle. And while I have time, I decided to film and show how everything connects and hooks up. Because, for example, someone seeing such a large number of wires for the first time might get confused and even be afraid to connect it all. But I'll now show you how simply it's all done. For example, this is a small 350 watts controller, or here's a larger 1.5 kilowatts controller that I have. They all connect the same way. That is, the connectors on the wires might be different, but the basic connection principle is the same. For example, I'll now show you how to generally understand these wires. This is how we can separate them. Here we see these are the thick power wires, and these are the thin signal wires. And it's the same in any controller. Here we take a 1.5 kilowatt controller. Here we also have the power wires at the top and the signal wires at the bottom. Not all of the signal wires will be needed. Maybe even more than half of them won't be needed. And now I'll show you how to connect all of this. Here they connect identically in principle. Here we have a three-phase hub motor. Mine is gearless. What comes out of it? 3 wires, 3 phases. Here by color, yellow, green, blue. And here are 5 wires. These are for the hall sensor. The hall sensor also has 3 signal wires here. Also by color, yellow, green, and blue. And the red and black wires are for powering the hall sensor. And similarly, we take the controller and look at what wires we have here. Here we have the power wires. The red and black wires go to the battery. Red is plus, black is minus. I don't have a battery yet, I'll be assembling it. Later I'll film the battery assembly process. For now, let's connect it to a 48 volts power supply. Power supply, 48 volts wheel. Controller from 48 to 72 volts. So it will seem like low power there. You can put a larger battery and we'll have a more powerful wheel. In short, 2 wires plus and minus for the battery. This thin red wire, it usually runs nearby. This is for turning on the controller. That is, we apply positive voltage to it and the controller works. We remove the positive and the controller turns off. This wire can be routed through a switch. It can be routed through an ignition switch. There are throttle grips with ignition switches. So this wire goes through a switch, disconnecting the controller. The same applies to this one. Here we have red for positive, black for negative. And the thin red one goes to the ignition switch or a button. And here are 3 thick wires. These go to the motor, matching the colors. We connect them the same way, ensuring the colors match. I don't have a 3-phase terminal box yet. I'll buy it later during installation. For now, I'll just assemble it with screws. We connect blue to blue, yellow to yellow. The same goes for green to green. Next, we'll need to connect the hall sensor. Also among the signal wires we have this one. This is the hall sensor. The connectors usually match. That is, hall sensors typically use the same connectors. Even a large controller and a small one. See, they have the same ones, so they usually match. It's usually different for the throttle. But for the hall sensor, see the connector matched, we connected it, and it's all set. Similarly here, 2 wires go to power, and 3 are signal wires. What else do we have here? We need to connect the throttle to the controller. For the throttle, I've taken a standard one, for example. With a voltmeter, you could use a twist grip throttle like on a motorcycle. But I took this one, it's smaller. The throttle connects. Red for positive, black for negative. And green is the signal wire. We find the same wires among this wire harness. Here I found them. Black for negative, red for positive, green for signal. Here we have 5 volts. Black is -5 volts, Red is positive 5 volts. Green is the signal volts. The signal goes from 0.9 volts up to 5 volts. So by using the throttle, you regulate the voltage on the green wire, and depending on that, the controller will regulate the throttle. But usually I see that they don't match. The connectors simply don't connect because they are bought from different sellers and therefore have different connectors. But this is not a problem. We just remove this connector and connect it. Or you can simply cut the wires and solder them together if you're installing everything permanently. I'll explain this little feature. I've pulled out the contacts and we connect them by color. So I connect black to black, green to green, and red to red. Done. Connected. The yellow wire is our positive lead for the voltmeter, so we can then connect it like this to any positive wire. It's usually connected to the signal wire that turns on the controller like this, and it will show the battery voltage. So regarding the connection, I've connected the main contacts, and basically everything is ready for the motor to operate. Now we will supply power and test it. We make sure nothing short circuits anywhere. And we'll also need the red one. When we connect it to the red one, the controller will turn on. So we've supplied power, everything is connected. Now for everything to work and turn on, we'll need to apply a positive charge to this red wire. Here we apply it. And our controller has turned on. Now we press the throttle trigger. And our motor wheel starts to rotate. And I see that it's rotating in the wrong direction. It should be spinning this way, but it's spinning in the opposite direction. To train the controller, here we have 2 wires. They are white with black connectors. To train it, we simply short them together like this. And the wheel starts rotating in the direction we want. Now we disconnect the wires and try with the throttle trigger, and now the wheel starts rotating correctly. Here's our maximum speed. We've turned it off. What other wires do we have here? We'll need to check and figure it out. Well, these 2 are for training the controller. They are clear. When shorted, the wheel starts rotating in the opposite direction. We also have an orange wire. This is our cruise control. To avoid constantly holding the throttle trigger and accelerating, we can fix the selected speed. For this orange wire needs to be shorted to negative. We have a black negative wire here. It could be the casing, or it could be this black wire, or you can take another one. For example, from the brake, the black is also negative. And if we short it at a certain speed, it gets fixed. Now I'll demonstrate how it works. So we've accelerated, for example, to this speed. To fix the speed, we short the contact. Not constantly, but just shorted and then disconnected. Here, let's try. I release the throttle, and our speed is fixed, and the wheel spins constantly, even if we're not accelerating. To disable it, we press the negative again without fixing it, or you can accelerate harder with the throttle than we were going before. So we've turned it off, we turn it on again. So the speed is fixed, we're riding. If we want to disconnect it, we accelerate and the cruise control turns off. We also have this kind of connector with 3 wires. It's like a gearbox. This limits our maximum speed. And there's an economy mode, which means a low speed. If we don't use it, don't connect anything at all. This is our medium speed. So we accelerate. This is our medium speed. And there's also a maximum speed. How does this feature work? We have a black wire, and we need to short it with either the blue or the brown wire. Or don't short anything at all. Here it's disconnected. This is currently our medium speed. I'll now demonstrate how it works with the black wire. We short either the blue or the brown. Let's short the blue one first. No, let's do the brown one. They're right next to each other. We accelerate. So this is our medium speed. We short it. The wheel starts to spin slower. The speed will increase. It decreases. And if we short the black and blue, that will be our maximum speed. So we short it, and the wheel starts to spin faster. We short it. This is the maximum speed. So we put a switch here and select the position medium, minimum speed, and maximum. By default, we will have medium speed. Well, once we assemble the bike, I'll show you how much the speeds differ if we use this switch. And for the remaining wires, I'll now tell you what I was able to figure out. Some I couldn't identify. But this one, for example, 2 wires, black and white, this is where the brake lever connects. So there should be some kind of button, a limit switch, that will short these 2 contacts. Black is negative. There are controllers with a single wire. So there won't be a negative, there will only be 1 wire. It needs to be shorted to ground, to negative. But here, 2 wires are already provided. 2 wires, I'll show you now. So we're riding. It's spinning. I'll short these with tweezers. So we're riding. And we short these 2 contacts, and the wheel stops spinning. So when we press the brake lever, release it, the wheel continues to spin. So this is installed on the brake lever. Similarly, we have this yellow wire. It's a single one. It's the same thing, but positive. This one shorts to negative, but this yellow one needs to be, if shorted to positive, the same thing will happen. Well, it's inconvenient for me to do that. So we apply positive here, and the motor wheel stops. These are 2 wires. 48 volts is constantly supplied here from the battery. So even if this red wire is switched off or switched on, 48 volts is always present. It can be used, well, as stated in the seller's description, meaning it goes to the alarm system. Or you can connect some other device. You can lower the voltage there via a converter, connect a headlight, or some other equipment, like a signal. So 48 volts power is always supplied here. These 2 wires here we have are for reverse. For example, if your bicycle doesn't need reverse, but for instance, if it's a 3-wheeled vehicle, a tricycle, then you'll need reverse. If you short these 2 wires and press the throttle, the wheel will rotate in the opposite direction. Here, with mine. Now it's spinning forward. I'm shorting the 2 contacts, like this. Shorted. The wheel is spinning in reverse.